Okay, so I understand the history, but why is it so popular now, and why was it not considered as important in the past? So, put simply, the key reasons are that ore bodies are and deposits are becoming harder and harder to extract and process economically. This is largely because the shallower, simpler, and less mineralogically complex deposits have been mined out. We're having to exploit deposits that are more complex from a lithological, mineralogical, and geochemical perspective. Minerals that are or were not considered as ore historically, due to processing issues, lower recoveries, higher costs to extract, are now being considered due to availability and demand. Commodities that were not considered historically are now being considered due to modern technological demand. And often these products are within geological terrains that have not been exploited for in the past and are more variable in nature and not as simple and homogeneous. The other reason is due to metallurgical processing and technological advancements. With greater complexities in ore bodies, together with the need to improve efficiencies and cost margins, processing developments have added to the overall picture. The operation of things like float cells or DMS circuits require fine tuning and steady state feed in order to run optimally and economically. And this requires much more detail on the incoming ore feed in terms of grade of the ore, grade of contaminants, size ranges, mineral species, gang minerals, etc., etc. If this information is known and can be planned, the process can run more smoothly and optimally. Lastly, final product specifications are a big driver on the saleability and profitability of the product. Often, contaminant elements or metals are considered more important than the primary ore mineral or metal. We now need to consider mineral contaminants within the deposits and estimate these grades or minerals the same as primary ore metals. Grade control is often defined by these contaminants and not by the main mineral. So, by understanding the variability of ore properties, companies can optimize the resource, reduce energy consumption, and minimize environmental impact. Implications for not understanding variability in geology and the effect on met performance can include poor recoveries, grades, production, revenue can be down, can often incur increased capex and opex costs, and ultimately, this could inevitably include mine closure and the project not being economic.